Yeah, so as Matt said, my name's Liam Betsworth. I work for AMPLYFI. I guess I see myself as a bit of a risk taker as well, but probably not as much as Ian, so I won't be doing any live demos in this. So hopefully everything goes smoothly. But yeah, basically, I've been asked to talk about our experience as a startup of using serverless, and so then this begs the question, server or serverless? Actually, I'm going to ask you, like, just a quick show of hands. So who votes server? Put your hands up for server. Anyone? Serverless? Okay, well, that's the end of my talk then. We've decided, right, serverless. Well, of course, right, it's not that easy. There's a few kind of nuances to it, which I'll talk through. First, I think it's important to understand who AMPLYFI are, and that'll give you the context of what we're trying to do with serverless. And then I've tried to break this down into some quick segments of some of the good things we found about serverless, some of the bad things, and then some of the really ugly things, some of the real bad pitfalls that we've fallen into. And then again, I'm going to revisit the question, server or serverless. Does anyone know what this number is? It's 130 trillion. Any guesses? Anyone? It's a pretty big number, right? So basically, this is the estimated number of web pages in 2016. That's a huge number, right? And this is 3 years ago now. Okay, so how many books is that? If we say each book is 250 pages, maybe, that's 520 billion books. And you might be thinking, okay, well, why am I asking this? Well, if you read a book every single day in your entire life, up until the age of, let's say, 75, you'd read 26,000 books. So of course, that's not 500 billion. There's a lot of books there you didn't read. There's a lot of information you're never going to access or be able to absorb. Basically, there's a lot of information out there. What we're trying to do at AMPLYFI is we work in the area of business intelligence. Now, conventionally, how business intelligence works is a company wants to find something out, they'll hire a bunch of analysts, and then these analysts will read stacks and stacks of data. They'll go through academic papers, online, they'll read absolutely everything, and then they will try and come up with their answers about what's happening in a certain area, what are the next big things, what's going on. And I guess the problem with that is coming back to what I just said. Humans can't read everything. That is just a human limitation. And at the same time as well, there'll be gaps in someone's knowledge, and then that leads to biases and things like that. What we're trying to do at AMPLYFI is we're not trying to take people out of the picture entirely, but we're trying to harvest huge amounts of information, process them, and then deliver them as really useful insights then back to users. The kind of insights that we're delivering back to people, so it's the kind of thing like the who, the what, the when, the where, and then even trends as well, as I said. So we're looking at the future and the past. How has technology progressed in the past? How will it end up going in the future? I'm just going to drop this in here quickly because you're probably wondering where we get our information from. So we get a lot of our information from the surface web and the deep web. Now, when I say deep web, people always immediately think dark web, and so I'm going to say no. We don't touch the dark web. We're purely just deep web. So deep web, what I mean by that is that we tap into unconventional sources that you can't find through search engines, for instance. So paid sources or something like that, or something that hasn't been indexed by a search engine. So then, where do I fit into all this? I have a background in human-computer interaction and computer science, and actually that puts me in quite an interesting location, because I'm kind of a designer and a researcher, but at the same time I'm a developer. And I guess that's why I got headhunted by AMPLYFI about a year ago. As you can imagine, there are so many challenges with this amount of data and trying to process it and trying to actually visualize it in any meaningful way for our users. So I guess that's what you could say I'm in charge of. I'm in charge of trying to take this big data and present it in a meaningful way. I've got lots of past experience with servers and Internet of Things. And then, so over the last year at AMPLYFI, we've been doing a lot of experiments with serverless and just trying to get to grips to it. And this is actually really exciting to me because so many things that I've built in the past would have been so interesting and potentially so much better if we had serverless, and now we do. And so the work that I'm currently working on is I'm working on re-architecting the APIs. Why would we use serverless? I'm not going to go into too much detail on this. You're all sold on serverless. The deployment, cost, maintainability, everything's awesome. It seems better in almost every single way. What do we actually use serverless for? So we use it for data processing. As data comes in, we use it for our APIs. That includes back-end and user-facing front-end APIs. And actually, quite recently as well, we've started using Aurora serverless as well. I don't really have any feedback on that yet because we've only been using it for about a week. But really cool, right? Databases, kind of like the Athena thing, yeah, using serverless and databases is pretty cool. So yeah, I'm going to run quickly through the good. So the good. In terms of data processing, it really, for us anyway, it gets the thumbs up. We run through periods of lots of data and then no data, and for us it's really good just to be able to switch the tap on and off. We're using event-based computing, so whenever something ends up in a queue or something ends up in a S3 bucket, it's just easy for us, straight off the bat to just knock in those things through as fast as we can. Again, scalability, concurrency, it's pretty good for data processing for what we're using it for. In terms of the bad, well, actually, I guess you could say this could be seen as a potential positive and a negative at the same time. It allows you to write in a lot of different languages, right? But this actually led to a problem for us. So we actually had one API that was written in, I think, three or four different languages. And that's almost impossible to maintain because you run into all kinds of problems like code maintainability and reusability. And we're writing the same code 3 times, essentially, in different classes. Why not write it just once? It actually forced us to agree on a single language, and in the end, we decided on TypeScript. Other bad things we've encountered, cold starts. I'm sure you've all heard about cold starts before. I asked for Jan's permission to borrow some of these images from, he's written loads of really good blog posts. He gave the keynote this morning. Yeah, essentially cold starts, if you don't know what they are, if the Lambda hasn't been hit for a long time, it just takes a little while to provision. In this example, just 1 second, and then after that, then it's kind of warmed up, and every request afterwards is just milliseconds. What happens when you send 10 concurrent requests? Well, you run into this kind of thing. It's a bit of a problem for us, because then when we've got loads of users hitting our APIs, we're going to see lots of people all over the place getting cold starts. Again, that's a bit of an issue. You can keep your Lambdas warm, which I'll talk about in a second, but then the problem you have is that even if you can keep one Lambda warm, you still have 9 that'll have a cold start when you run into this situation. So that's a problem we're battling right now. And then language choice. So actually, we didn't realize when we first started choosing our languages, but language has such a large impact on the cold start time. Again, this is some of Jan's work, but you can see, right, 5 to 6 seconds for a statically typed language. So if you're using Java or C#, you're talking up to 6 seconds delay, which is not acceptable, really, if you're making user-facing APIs. And then just to demonstrate this again, kind of like as you provision more memory, the cold start times go down. But essentially, yeah, you're talking 5 or 6 seconds. Node and Go are actually very good. As you can see towards the end of the graph there, there's barely any cold start time, which is why we've moved in that kind of direction. Yeah, as I said, you can try keeping the endpoints warm, but eventually they're all going to die at some point. After about 60 minutes, they're probably all going to die, and then they'll have to start again. So the ugly, can anyone think of what the ugly might be? I'm sure some people might have some ideas. In this, we seem to have walked into what I call the perfect storm. So essentially, everyone says don't do this, but we've ended up in this situation where we have to protect our data in a VPC, but now we have this problem of VPC cold starts with statically typed languages and sparse, rarely used endpoints. It takes 10 seconds to make an elastic network interface so that the Lambda can talk outside of your VPC. That's up to 10 seconds. Then we're talking about the C# Lambda invocation, 6 seconds. But often 16 seconds for a response in the API. That's just like crazy. And especially then when you imagine, okay, we've got 70 different endpoints we're hitting. 70 times 16 is a lot of time to be waiting around for something to happen. So what have we learned? Basically, I would say avoid serverless for responsive user-facing APIs. Avoid statically typed languages if you can, because Node and Go are better. Whatever you do, do not use a VPC, because it's just like the bane of our existence right now. And if you ignore everything I've just said, please at least use a CDN to cache your responses or something. That's kind of thrown us a bit of a lifeline in that in some instances, we'll get like the 5-second cold start, but then after that, it's fine. It's cached, and people will get the cache forevermore until something changes. So then back to my original question then. So serverless or serverless? It's a bit of a cop-out answer, really, to be honest, and you were probably all expecting this. I don't think there is an answer. There are some applications which serverless works really well for, and there are some which server work for. In terms of well, where we go from here, as I said, we've recognized that serverless is not a one-size-fits-all. There are some things where long-running processes just work better, or user-facing APIs may work better in terms of Elastic Beanstalk. We actually came up with a pretty novel and neat solution, I think. I don't know of anyone else who's actually doing this. We've come up with this process of, we write, well, some of you may frown at this because it doesn't really follow the microservices approach, but I'm okay with that, it works for us. Essentially, you write your endpoints once in Express, and then using Express and AWS Serverless Express, you can basically throw any wrapper you want around it, so we can actually deploy our APIs on serverless, or at the same time, we can deploy them on Elastic Beanstalk. And again, that throws us a massive lifeline. If we decide further down the line, this would work better on Elastic Beanstalk, we can go that way. If it works better on serverless, we go that way. You write the code once, and it can be deployed twice. And that's my talk. Yeah, I know there's no time for any questions, but if anyone wants to speak to me about what we do, come and see me. Thank you.